Hi, this is another question from the WASSCE private last year, and in it we asked to find the length of line mx. So in the preamble, according to the preamble, we have the length of line mn to be 5 meters, okay, and the length of line xy to be 15 meters, the length of line ny to be 18 meters. Calculate correct to one decimal place the length mx, so the length mx here, and also the angle of depression of m from x. Now, starting with the length mx, to find length mx, we'll realize that r, we have been given that the line, we have been given from the diagram that the angle MNY here, which is 90 degrees, is it's equal to the angle XYN here, which is also 90 degrees. So this means that the two lines from there are parallel. So this line MN and the line XY are parallel. So if they are parallel, we can draw another parallel line to the line NY. Okay, so by drawing a short dashed line through this, okay, so we have this line here. So we have a new parallel line. So if you have a new parallel line, okay, so a new parallel line to the line NY, that means that new parallel line is also 18 meters, and the angle that will be formed there with the length xy is 90 degrees. So looking at since it's not drawn to scale, you know that it's not drawn to scale, so looking at this, we realize that the mn is also parallel to, since it's parallel to the mn, since it's parallel to the yn, we realize that the length mn will be equal to the length here, our new length here, from here to here. Okay, so let's say this is a z. Okay, so that will be, so our mn will be equals to the mn, line mn will be equals to the line zy, okay, which will be equal to 5. So if that is 5 meters, okay, so that means that our zx, okay, zx here will be 10 meters, since from y to x is from y to x is 50 meters, and z to x plus z to y is equal to x to y. Okay, so we have 10 meters. So that means that for this we can use Pythagoras theorem, okay, to solve for our line mx. All right, so we have our diagram as shown on our screen. Remember that it's not drawn to scale. Okay, so we can now pick this part of the diagram and solve it by Pythagoras theorem. So we have something like this. So here to be 18 meters and 10 meters. Remember, this is what we're looking for. That's our line mx. So we have mx sorry, mx line mx square will be equals to 18 square plus 10 square, okay, which will be equals to 424, the line ms square. Then since we are looking for the length of the line mx, so we square root both sides. So we have line mx, the length of line mx to be equals to the square root of 424. So that will be the length of line mx to be equals to 20.6. So to the nearest to one decimal place. Okay, so it's an approximation, approximately 20.6. Okay, so that is that for our length. So we use the same approach to get the angle of depression from x to m. So that means we'll have so with the same triangle, so we have this, okay, m and x. Okay, so that means that since it's a right angle triangle, the angle of depression will be the horizontal line from the horizontal line, the angle between the horizontal line and the length, okay, the length of the line mx, so the line mx, so that is here, the angle here. So but when we look at this line, this horizontal line that we've created, the horizontal line together with the base line mz are parallel. So if they're parallel, that means the angle here and here are the same. So in other way, what it means is that the angle of depression is alternating to the angle of elevation. So at the bottom there, so we have, so let's say this is theta, so we have tan theta being equals to the opposite. Remember, the opposite is, our opposite here was 10 and here 8, so 18, sorry. So tan theta equals 10 on 18. So since we are looking for theta, so it will be theta equals the tan inverse of 10 on 18. Okay, so we have we press the tan inverse of 18, so we have theta equals the tan inverse of 10 on 18. Okay, and the tan inverse of 10 on 18 will give us 29.05 degrees. Okay, running to the nearest whole number, we have running to the to one decimal place, we have 29.01 degrees. Sorry, 29.1 degrees. Okay, sorry, 29.1 degrees as requested of our as requested of us from the question. So 29.1 degrees, and that brings us to the end of today's solution, to the solutions to the problem that we have there. So thank you. We meet again next time. Like the video, share it to your friends, and remember to subscribe and activate the notification button.